It's day 8 already, and we are getting to the big guys. This is one of the very, very pivotal topics that you would come across in physics. If you have not made your peace with motion, especially linear motion, then a lot of things in physics will be a challenge to you. They will be very, very challenging. And I'm going to try as much as possible to give you every bit of a detail that you need in this particular class on this very day. So if you are currently on this premiere, I want you to invite your friends to join as well because it's going to be very, very awesome one. And get your notes, get your pen. We are about to get into business. Linear motion. What is linear motion? Now, let's talk about motion first. Motion is, simply put, is movement. When you say motion, you're talking about movement. So anything that has to do with changing from one position to another, then that is motion. So when we now say linear motion, then we are talking about a straight line motion, a rectilinear motion, a motion that takes place from one point, so let's say point A, to another point, let's say point B. Now, this motion, somebody can move from point A to point B, but they can also decide to change from point A to point B. They can decide to move to another point, let's say point C. They can decide to move to another point, let's say point D. And they can decide to move to another point, let's say point E. And they can continue to move like that till thy kingdom come. So there will be several linear motion involved in this process. All of these will be rectilinear motion. And so the analysis of all of this rectilinear motion of this person altogether is what we'll be considering in this case. So, like I've defined, motion is simply movement, the change in position from one point to another. Now, here's the thing that gets involved when we talk about motion. The number one thing is that there is always a length that you cover when you are going through motion. And by the way, I'm going to be talking more about linear motion today. So if I just say motion, just know that I'm talking about linear motion for this particular video. Now, there's always a length of time. Sorry, there's always a length that you cover. And one thing about all these events is that they do not happen in the absence of time. So time is involved, a length is also covered as well. So in this concept of covering a length during your motion, then we introduce the concept of distance and we introduce the concept of displacement. So distance and displacement, what exactly differentiate the two of them from each other? Because both of them are measuring the length covered during a particular motion. So distance has to deal with the fact that if you cover so many different parts, if you moved in different ways, all the total parts that are covered. So let's say, for instance, this one you covered it x1, this one you covered it x2, this one you covered it x3, and this one you covered it x4. So all of these parts, individual parts that you have covered, for the first case from A to B, you can say that that is actually directional. You are going directly towards B. In this place, you are going from B to C, from C to D, from D to E. But you can't actually pinpoint that this person was heading towards E right from A, because when they started from A, it looks like they were going this way. And if they had continued that path, this is where they would have headed. So you wouldn't have predicted that this person was heading towards E. Fine, when they were moving from B to C, it looks like they were going towards C. But when they started moving from C to D again, the whole thing decided to change dimension again until they eventually made it to E. So all of these parts that were covered, x1, x2, x3, and x4, when you sum all of these things together, then that is what we call total distance covered. But x1 itself is also a distance. You see, that's the thing about distance. Distance is all encompassing. So whether it is done in a specific direction or it is done as a collective thing altogether, it is still distance. But for distance that are done in specific direction, we give those ones a special name, and the special name is called displacement. So I believe that helps you clear thing between what we call distance versus what we call displacement. So there is distance and there is displacement. Distance is the all-encompassing word for any length that you travel from one point to another. But displacement is a specific type of distance the one that you move in a specific direction. So, in other words, just like we have done in the previous class, there is scalar quantity and there is vector quantity. Distance is scalar, while displacement is what? Is vector. Now, displacement, like I said, is a distance moved in specific direction. It can also be regarded as the shortest distance between 2 points. So look at this person now. Instead of dilly-dallying and then just moving haphazardly up and down, going through x1, going through x2, x3 to x4. Now, where they could have just headed, they could have just decided that they want to head from A directly towards E. And this path that they are supposed to follow is going to be the path of displacement. It's going to be the path of displacement. What displacement? Displacement from point A to point E, because point A to point B is also a displacement. Point B to point C is a displacement. All of these, there are several displacements, but when you talk about the entire journey in total, there is a net displacement, and this net displacement is simply a difference between the final position and the initial position. So displacement is difference between final position and what? Initial position. So quickly, let me show you how to find displacement. One way you can find displacement in a very simple way. So let's say somebody moved, let's say I calibrate a point on this line. And let's say I've calibrated this point. Let's say this is point 1, point 3, point 5, point 10, point 12. So I've calibrated this thing now. So let's say somebody started a journey. Let me see. One name that pops up randomly in my head now is Isaac. Let me just use my name. So Isaac started the journey from here, and Isaac was going to travel. So Isaac traveled from this place to this place. So when Isaac got here, Isaac decided to, continue the journey and moved again and moved and got back here. So Isaac decided to move and he got back here. So the starting point of Isaac is this. So Isaac started here and the journey of Isaac ended here. So this is the end point. So how do you find the displacement of Isaac? The displacement of Isaac is simply its final position, which is 1, minus its initial position, which is 3. So this is going to be what? Negative 2 meters. So let's assume that all these things are measured in meters. So Isaac has covered a displacement of negative 2 meters. What does this mean? This means that Isaac had gone kind of backward in terms of his perspective from where he started from. So he started from 3 and he went to 1. So does it really matter what Isaac went through throughout the process? It does not really matter. But if what we're going to look for is the distance covered throughout this journey, so the first thing that Isaac did was that Isaac moved from 3 to point 10. So the first distance, so let's call that one x1. So distance will be x1. So Isaac then moved backward to this place. So x1 plus x2. So what is x1? x1 is from 3 to 10. So that will be 10 minus 3. So the distance between those two places would be 10 minus 3 plus. Then Isaac then moved again. He moved from 10 to 1. Now, in this situation, because we are looking for distance, we are not looking for displacement, we use the absolute value. That is, whatever difference that we get, we will always use their positive value. So we have difference of 1 minus 10. So 10 minus 3 is 7 plus 1 minus 10 is negative 9. But because we are taking the absolute value, because we are dealing with distance and not something directional, so that will still be what? 9. So the total distance covered by Isaac would be 16 meters. But their total displacement is what? Negative 2 meters. So that is in one dimension. In two dimension, I'm just going to give you, because of time, I'm not going to be giving you too much details. In two dimension, so this point can actually be described using, let's say, some x initial, comma y initial. So giving a point on the x coordinate and giving a point on the y coordinate. So this one can be x final and this is what? Y final. So the displacement can then be given as the square root of x final minus x initial squared plus y final minus y initial squared. So that is what the displacement will be. And for the total distance covered, all you have to do is that you have to calculate what x1 is, what x2 is, what x3 is, and what x4 is. Then you add all of them together, and that's how you get your displacement. So having said that, I can't say too much in this video because I know this video is going to be lengthy already. So I'm trying to cover as much details in short time. Now we're done with distance and displacement. Then let's go to the fact that you don't cover distance, you don't cover displacement without time being involved. As you do this thing, as you move, time passes. So because time passes, then it implies that somebody who covers, so I can use displacement, I can use distance for anything I want to talk about. So just know that whatever I say for distance, it's kind of similar for displacement as well. So I'm going to be using them interchangeably. So let's say somebody is going covering a particular distance. This person is covering a distance of, let's say, 5 meters. Then a person, so this is person A person B is also covering a distance of 5 meters. So apparently, these two guys don't have any difference between them. So, but as time passes, let's say for this person, only 2 seconds passed, and this other person, only 1 second passed. So you begin to see that now there's a difference. Even though they are covering the same distances, but the time that passed when they covered this distance is not the same. And that is where you introduce the concept of, okay, what is the rate at which they are doing this distance covering? So the rate at which distance is being covered is what is known as speed. So therefore, the concept of speed equals what? Distance over time. So the rate at which this distance is being covered per time is known as speed. However, speed in itself is actually fictitious in nature. Don't mind my English. What I mean is that it is actually fictitious in nature. That's a very, very big English. What have I done to myself? Anyways, let's come back to this. What I mean by that is that it is technical. It is in real world. It is very, very, very technical to use the word speed just light around like that. So in physics, what we actually employ is what we call average speed. So in physics, we use more of average speed than what? Than just the word speed. What is the difference between these things is that you see somebody who covered 5 meters in 2 seconds. There are so many things that could happen in that time period of 2 seconds. So 2 seconds. So it's possible that chunk of that 4 meters, it's possible that maybe 4 meters out of this whole thing, in the first 1 second, they had covered 1 meter. And the last 1 second, they only covered 1 meter. I'm going to give another example. It's possible that this person in the first 1 second they already covered, let's say, 3 meters, and in the last 1 second they covered the 2 meters. So you see that I can begin to give you a lot of permutation of these things now. I can give you for 0.5 second, I can give you like this is for person A. So therefore, if you say that their speed is distance over time, that implies that you always say 5 over 2. So that implies that at any point in time for any of these scenarios, scenario 1, scenario 2, scenario 3, you will always say their speed is the same thing. But that's not going to be true because they really possess different speed at different time and at different points. So we now use the word average speed, meaning that after all the collective movement that they have done, they shall covered 5 meters in 2 seconds, and we use the word what? Average speed. So speed is actually more of something that is more of a concept than a real life thing. So however, if this person they move at a very, very uniform rate such that they are covering equal distance in equal time interval, even though that is also not very, very realistic because it means that you have to break the time down into very, very infinitesimal second. So anyways, average speed is what we deal with mostly. So an average speed is given as the total distance over total time taken. So average speed is what we use mostly in calculation. Now the same thing with the concept of velocity as well. Velocity, this speed is to distance, while velocity is to displacement. So therefore, we have velocity, which is displacement over time. But also, we make use of average velocity more. We make use of average velocity, which is given as v bar. Then that is what? Total displacement. Total displacement over what? Over total time taken. So I'm going to be showing you how we get all of these things very soon. Now, because of time, I won't really say much about this average velocity thing. So when we are about to have our live classes, so especially in the comment as it is now, I want you to drop as many clarifications that you would need. So when we have our live session, this is going to be one of the very, very important class that we discuss a lot about. I would love to answer as many questions as possible from you. So make sure you are in the comments and then you drop as many things as you need to clarify. Also, we meet on the community page to discuss more. So now let's proceed. So I'm going to pen whatever it is I want to describe here now. Let's proceed to the next guy. The next guy is called acceleration. Acceleration. So acceleration is now, so displacement, you are covering a displacement in a given time. So therefore, you have velocity, meaning that there is a rate at which you are moving from one position to another in a specific direction with respect to time. But here's the thing, you can actually decide to increase the rate at which you are doing that. Meaning that if you have been covering 2 meters in 1 second, you can decide to say, I don't want to cover 2 meters in 1 second again. I want to be covering 5 meters now in 1 second. What you need to do is that you need to change your velocity. And this change in velocity is called acceleration. So the change can be an increase in velocity, that is acceleration, or the change is decrease in velocity, known as deceleration. So therefore, generally we say acceleration is the change in velocity over what? The time taken. So for the sake of this particular video, we're going to be using v for final velocity. V will represent final velocity and u will represent initial velocity. U will represent initial velocity. So therefore, acceleration can then be written as v minus u divided by t. So that implies that this can be a deceleration and this can be acceleration. So if it is acceleration, v will be greater than u. And if it is deceleration, or what is also called retardation, then v will be what? Will be less than u. So, however, in the linear motion part, we're going to be dealing with what we call a uniformly accelerated body. A uniformly accelerated body. So let me take it back a little bit. What does it mean for something to be uniform? It means that thing is the same. So if somebody has, let's start with uniform velocity. Like I said earlier, I've already explained that somebody can be covering a uniform velocity, so that they are changing displacement in equal time interval. So when you say somebody has uniform velocity, that means that they are covering equal displacement in equal time interval. It doesn't matter. So if they cover 3 meters in 2 seconds, that means that they will cover 5 meters, sorry, they will cover 6 meters in 4 seconds. They will cover 12 meters in that should be 3 meters in 2 seconds, so that's that will be in 8 seconds, like that. So that's how it goes on and on like that. So this is uniform velocity. Now, when the velocity is uniform, what it means is that the final velocity and initial velocity are going to be the same. So what can we say about acceleration then? If v minus u, if v and u are the same, that means that v minus u is going to be equal to 0 and acceleration is going to be equal to 0. So that means that anytime we have uniform velocity, then acceleration is going to be equal to 0. But we can take it up a little bit as well. We can also talk about uniform acceleration. Since acceleration depends on change in velocity, so we say acceleration is change in velocity over time. But if this change in velocity is equal for equal time interval, is equal for equal time interval, then we say we have uniform acceleration. This is different. The difference here is that velocity is changing. In the previous case, when we say uniform velocity, velocity wasn't changing at all. But in this case, velocity is changing, but it is changing in such a way that whenever it increases from 1 to 3 for 1 second, it will move from 3 to 5 for another 1 second, it will move from 5 to 7 for another 1 second. So there's always what we call a uniform change in velocity. So, and when you have that, you have what we call uniformly accelerated motion. Uniformly accelerated motion. So I'll be calling it the UAM, uniformly accelerated motion. And it is this uniformly accelerated motion that now lead us to most of the equations that you are familiar with. These equations, they are called the equation of uniformly accelerated motion. So we have what we call the equation of uniformly accelerated motion. So for the equation of uniformly accelerated motion, we are going to start from the equation of acceleration itself. A is v minus u over t, and what that implies is that I can cross multiply. So that means that if I say this is divided by 1, so 1 times v minus u is v minus u, then a times t is at, and this implies that v is going to be equal to u plus at. That is me taking negative u to the other side, and it becomes positive u. So you can call this one your first equation. Take note, this equation is an equation of uniformly accelerated motion. It is not the equation of motion, because there are different motion, and this equation is only applicable for uniformly accelerated motion. It does not work for all types of motion. So let's get into it. So now, having said this, then let's go back to some things that we have mentioned earlier. If velocity is changing, and then because velocity is changing, then we have acceleration. So we have average velocity as well. Like I told you, average velocity is total displacement divided by what? Total time taken. So average velocity is the same thing as total displacement divided by time. Then this average velocity is actually also initial velocity plus final velocity over 2. Initial velocity plus final velocity over 2. Take note, I'm using S as displacement. I'm using S as displacement. So now this V bar is average velocity. So take note of something here. You can't say velocity is displacement over time when you are dealing with uniformly accelerated motion. Just like I warned you earlier, we don't just throw the concept of velocity equals to displacement over time around like that. We only speak like that in reference to dimension. But what we say is average velocity is displacement over time. So the only way this is going to be true is if there is uniform velocity. And the moment there is uniform velocity, there is no acceleration. So unless this body is not accelerating, it is neither accelerating, neither is it decelerating. If it has zero acceleration, that is when this can only work. So for every time that you do not have any information that speaks about the fact that acceleration is zero, then always stick with the fact that average velocity is displacement over time. And average velocity is also the addition of initial velocity plus final velocity over 2. However, take note, in the case of, this is only true, this u plus v over 2 is only true because we are dealing with uniformly accelerated motion, which is also a linear motion, a rectilinear motion. If it is not this case, then average velocity can't just be thrown around as u plus v over 2. It can't just be thrown around as u plus v over 2. But anyways, we are there already. So what I need here is that I want to combine these two together. So since s over t equals u plus v over 2, so that implies that s equals u plus v over 2 multiplied by t. So I just brought t to this other side, and you can call this one equation 2. You can call this one equation 2. So after getting that, this is what I want to do. From equation 2 and equation 1, I want to combine them together. So I can have that S will then be equal to, so this is U plus V in equation 1 is U plus AT. So everything divided by 2, then multiply by t. So what have I done? I've replaced V here with U plus AT. So this implies that S is then going to be 2U plus AT divided by 2 multiplied by t. So if I continue with this, I can split the fraction so that this is 2u divided by 2 plus at divided by 2. So in mathematics, you can split fraction like this. Everything here multiplied by t, and that implies that s equals, so the 2 can cancel out here. So you have 2 cancelling out. So you have u left plus at over 2. And finally, you can then decide to open the bracket with this t out here. So s equals u multiplied by t, that's ut, then plus, this is half of a, then t multiplied by t, that will be t squared. So you can call this one your equation 3. You can call this one your equation 3. Now, finally, I want to get the expression, another expression from v equals to u plus at. So from equation 1, from equation 1, we say that v equals u plus at. Permit me to square both sides. So if I square both sides, I'm going to have v squared, then u plus at squared. So this is going to be v squared equals, when you square it, you have u squared plus 2uat plus a squared t squared. Now, so what I want to do here is that I want to manipulate my way around this last part, and I want to get this expression out of it. So this is going to be v squared equals u squared plus, so if I want that to be, I want u and t to be left alone first. So this is u, this is t. So the two things that I need to bring out will be 2a. So I can bring out 2a from this expression. And what will I have left there? I will have ut plus. So, but in this particular expression, I have factorized 2 out, but there's no 2 inside here or any multiple of 2. So the only thing I can use to negate that is 1 over 2, because I know that if I multiply 2 and 1 over 2, I will get 1. So since the coefficient here is 1, so I can easily say 2 times 1 over 2 is 1. And I've brought out just 1a from there, so that means that another a will be left inside. And t squared, nothing has happened to it. It remains like that. So if you look at this very well, this is the same thing as ut plus half at squared in equation 3. So therefore, v squared equals u squared plus 2a. So the entire thing here can be replaced by the displacement s. And you can call this equation 4. And these 4 equations are the equations of uniformly accelerated motion. Sometimes, some places, it is regarded as the Shewhart equations. Shewhart equation. S for displacement, U for initial velocity, V for final velocity, A for acceleration, and T for time. So the Shewhart equation. Now, having described all of that, so I've been able to explain majority of the things that go on here. Now, there is a movement that has to do with upward and downward movement. I'm not going to talk about that here. So I think in one of the days, we will be discussing projectile motion. So I'm going to discuss about that better there. And under that projectile motion, I will also discuss about the the velocity time graph, and acceleration time graph, because I don't want this class to be too long. I've already given a lot of things for you to digest already, so I'm going to limit it a little from here. So a quick run through of what we have done so far. From the beginning, we talk about displacement, we talk about distance, we talk about speed, we talk about velocity, and then the concept of average speed. You need to really pay attention to that very, very well. So if somebody can cover a big distance and the displacement is going to be 0, so you need to pay attention to that. By the way, I'm going to be ending the class here for today. Make sure you share this video with your friends and like the video as well. Subscribe to the channel. That's one of the way you are supporting these 50 days of tutelage. Like that's that's the least you can do. So I guess I'll see you around for the tomorrow's class. Bye.